Hello there. This is a video for topic 3. I'm going to look right down the bottom, 3839310. It's the stuff on eclipses. So we're learning about solar eclipses and lunar eclipses. A few videos to watch and a small bit of information from me. You can pause the video to do the diagrams, make the brief notes. So here's just some images from partial eclipses. First of all, so it's the sun. I mean, you might think that's the moon behind the clouds, but you can see the sun is being blocked out, and this round thing blocking out the sun is the moon. So those are solar eclipses. So the light from the sun is being blocked out. Here's some more images. So if you were to see a total solar eclipse, that's the very special one. Lunar eclipses happen fairly commonly. A total solar eclipse happens on the Earth once every 18 months around. In any singular place on the Earth, it will only happen once every 400 years. And I think the next one in Britain will be the 12th of August 2026. So you might have to travel if you want to see one before then. So as the light from the sun starts to disappear, you still wouldn't be able to look at it. You need special glasses. It starts to get, this is some part of the eclipse. You get what they call a diamond ring. There it is. Bailey's beads, quite famous. And there we go, totality. And in totality, a very special part of the sun becomes visible. See, this is the solar corona. The solar corona is a lot hotter than the rest of the sun, and nobody's sure why, to be honest. It's an awful lot hotter. You know, if you were to walk away from a fire and it got hotter, that would seem weird, but that's essentially what happens with the sun. So this area around you never see, because the photosphere, the surface of the sun is so bright, you just never get to see the corona, but you do see it when the photosphere is completely blocked out by the moon. There we go, some more images. So there's a lovely image of the solar corona. You can see them kind of, it's got a magnetic field line associated with it. Alright, so here's a little diagram. Come across a couple of terms there. Umbra is Latin for shadow. So the full shadow is called umbra, and the partial shadow is penumbra. Pen could be translated Latin, I think, into almost. So almost in shadow. So try and think about standing here, just outside of that little shadow. If you're standing here, you'll be able to see the bottom of the sun, but you won't be able to see the top. So you'll be involved in a partial eclipse. But here, anywhere in this little dark circle here, you can't see the top, you can't see the bottom, you certainly can't see the middle, so the sun is completely blocked out. So during a total solar eclipse, this little shadow gradually moves across the Earth as the Earth spins. So only if you're in that shadow will you see a total solar eclipse. A few years ago when we had a partial solar eclipse, I think you could have gone down south of England to see what a total, but we just got a partial. Okay, here's another couple of diagrams which you might want to pause here and you get a simpler version of the diagram. Now, there's a few terms which crop up as well. We've talked about penumbra, almost in total shadow, so that's where you get a partial eclipse. And the umbra is where you get a total eclipse, and we'll talk about the antumbra in a minute. This is as simple as it gets, really, but this diagram would be the one to draw in the exam. It's probably normally worth about 2 marks if you were asked to draw a total solar eclipse. Really, you just got to get the Earth, Moon and Sun in the right order. There's another video for you to watch. I'm going to skip over that. And then this is interesting. You see, the approximate distances to the Earth and the Moon are here. And the ratio of that is about 400. So the Sun is about 400 times further away than the Moon. And guess what? If you look at the diameter of the Sun and the Moon, the ratio is equal. So there's no reason for that. It's a cosmic coincidence that the moon looks about the same size as the sun in the sky. I mean, isn't that amazing? So this is a short video. I'm limited to 5 minutes at the moment until I change the way I'm doing the videos. So this will be the first half, and then if you click on the second video, we'll talk about what impact this has on the eclipses.